Hello, how are you guys doing today? Hope we're all having a great day. We're going to go ahead and work on systems of equations, some more practice on our different systems. So we're going to be working on using substitution and using graphing for this. So we're going to start by reviewing the problems that were your homework from last night. So I'm going to start with this first problem set. So I've got two equations, x plus 2y equals 2x, or equals 2. 2x plus y equals 7. Remember that regardless of whether I'm solving with graphing or solving with substitution, my very first step is to put the equation in y equals mx plus b form. Okay? So I'm going to start with this first equation since it's clearly not in y equals mx plus b form, and I'm going to convert it. So I've got x plus 2y equals 2. Center of my equation is my equal sign. And the goal is to get y by itself like it is up here in the mx plus b format, or slope-intercept form. So to get y by itself, the very first thing I have to get rid of is this x. Since this is a positive x, to get rid of it, I'm going to subtract x. Anything I do to this side, I have to do the other. X minus x is going to cancel out. I now have 2y is equal to 2 minus x. I'm now going to go ahead and separate the 2 and y. Since 2 and y are multiplying together, I need to divide by 2 to get rid of the 2 and y. So anything I do to one side, again, I have to do to the other. So now I'm going to simplify it. 2 divided by 2 is 1. A negative divided by a positive makes a negative. And x divided by 2, well, I can't do that. So I'm going to remember that there's an invisible 1 right here. 1 divided by 2 is 1/2 x. So now I have this first one done, and I'm ready to graph it. I always graph using the y-intercept first. So my y-intercept in this case is 1. So I'm going to put my first point on my y-axis at my y-intercept, which is 1. So it's going to go right here. After that, I'm going to use my slope to help me with the rest of my points. Since my slope is negative, that means I'm going to go down. Since rise is over run, I'm going down 1 and over 2. So down 1 over 2, 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 and down 1 over 2. Remember that when graphing, we always move left to right. If for some reason we have to go and reverse that and move right to left, then we're going to reverse our directions. So to reverse, to go right to left, I need to go up 1 over 2. Up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, and up 1 over 2. So there is my first line. Okay, I have my first line done. So I'm going to change colors and do my second line. Let's do a blue for my second line. So this line is done. Let's do my second one. So again, I need to put in y equals mx plus b form. Center of my equation is the equal sign. I got to get y by itself. In order to do that, I first have to get rid of this 2x. So I'm going to subtract by 2x on each side. Anything I do to one side, I have to do to the other. Okay, 2x minus 2x is going to cancel out. So now I have y equals 7 minus 2x. Since there's nothing else with the y, we're all done here and we're ready to graph. Once again, when we start with our graphing, the very first thing we start with is our y-intercept, or our b, the number that's not attached to x. Since 7 is my number not attached to x, that's where I'm going to start. So I'm going to start at 7 on the y-axis. So I go up 1, 2, 3, 4, 5, 6, 7. Okay, then I have my slope. My slope is -2. Remember that slope should always be a fraction to help us find that rise over run. To make -2 into a fraction, I'm just going to put it over 1. So it's down 2 and to the right 1. So we're going to go down 2 over 1, 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 down 2 over 1. Reverse on to go to my right to left. I'm going to reverse it and go up 2 over 1, up 2 over 1. Now I have my line, so I can draw it in. Okay. Ooh, that was not a good drawing. Let's see if I can undo that one line there. Just that one line. Ooh. It's okay. It happens. I recommend that you guys at home are using a ruler or the straight edge of a paper to help you so you don't get the really bad line that I just drew. All right, that one's a lot better. Okay. So then we can clearly see that this is one solution. I could have seen that this was one solution in two different places. One, I could see it's one solution because I have different slopes. My slope here is 2, and my slope here is 1/2. Whenever my equations have different slopes, that automatically means it's going to be a one solution problem. But I also can see it in my graphing because there's a solution right here. So now I'm going to write my point. Remember, my coordinates always do an x and y point. And then x comes first, followed by y. To find my x, I'm just going to go up to the x-axis, and then I'm going to count how many points I'm across. That's 1, 2, 3, 4. And to find my y, I'm going to draw over to my y-axis, and it's at -1. So there is my solution. So that's how we find it with graphing. But we're going to practice substitution as well because you have to be able to do both methods. With substitution, the point of substitution is that we're plugging in for y. Okay? So what we're doing with substitution is the first step is we convert it to y equals mx plus b form, which we have. Then we're going to plug in for y. To do that, for each equation, we're going to cross out the y here because this is what y equals. So we're going to cross out our y's and set them equal to each other because we know that both of these equations equal y, so they're the same thing, so they should equal each other. So 1 minus 1/2 x equals 7 minus 2x. Now I'm going to bring all my x's to one side and all my numbers to another. Okay, for the sake of this, I'm going to bring my x's to the right and my numbers to the left. You could have done the reverse. That's totally fine. Center of my equation is the equal sign. Since I'm bringing my x's to the right, I need to move this x on the left-hand side over. It's a -1/2 x. So I'm going to add 1/2 x to both sides to move it over. Okay, 1/2 x, -1/2 x plus 1/2 x crosses out, leaves 1. Okay, 7 minus 2x plus 1/2 x. Let's see. Let's do 2x, -2x plus 1/2 x. Okay, right now I can't add them because they're not both fractions. So I'm going to go ahead and make this into a fraction. So it's 2/1. But I still can't add them because they don't have common denominators. So I have to multiply my denominator by 2 so that way I can get them to have the same denominator. When I multiply a denominator by a number, I have to multiply the numerator by it as well. So 2 times 2 is now -4/2 plus x plus 1/2 x. So when we add these, we're going to keep the denominator and our x. So now let's add them. If I owe you $4, but I have 1 in my pocket, then I'm going to owe you 3 at the end of the day. So it's 3/2 x. So now I'm going to bring down my 7, and I'm going to subtract 3/2 x. Now I need to get my 7 over to the other side. To do that, I'm going to subtract 7 on both sides. If I have $1 but owe you 7, I still owe you 6 at the end of the day. So 6 equals -3/2 x. Okay, now I have to undo this -3/2 that's times x. So remember that a fraction says -3 times x divided by 2. So to undo it or do the opposite, I have to flip it. And I have to do, instead of divided by 2, I have to do times 2. And I've got to multiply by that negative to undo that negative. And instead of multiplying by 3, I have to divide by 3 or multiply by the reciprocal. So those are going to cross reduce and cancel out. Anything I do to one side, I have to do the other. So it's times -2 divided by 3. I'm going to put this -6/1 so that I can multiply them together. And then I'll cross reduce. 3 goes into 6 2 times. A negative times a negative makes a positive. 2 times 2 is 4/1. 4/1 simplifies to 4. And since these crossed out, I'm going to bring my x down so I know x is equal to 4. Now that I've figured out what x is, I need to plug x in one of these equations. I can pick either equation to plug it in for. I'm going to do this one right here. So I'm going to change my color again. Y equals 7 minus 2 times And I'm plugging 4 in for x, so I'm going to put the 4 in here. Okay. 2 times 4 is 8, so 7 minus 8 is equal to y. 7 minus 8, well, if I have $7, but I owe you 8, I still owe you 1 at the end of the day. So now it's negative 1. So now you've got our x and our y, and if you checked, it matches our point. So we know that our substitution was done correctly. All right, time to move to the next problem. If you need to pause here to get all this work, please do so. All right, so we're going to move on to our next problem. Remember that our first thing we need to do is make sure each equation's in y equals mx plus b form. Since neither of these equations are, we're going to convert them both. So I'm going to start with this one. X equals negative 2, y plus 4. Okay, center of my equation is my equal sign. I need to get y by itself. So the first thing I'm going to get rid of is this 4. To get rid of 4, I'm going to have to subtract by 4. Anything I do to this side, I have to do the other. So now I have x minus 4 is equal to negative 2y. Now I have to get rid of that negative 2. Since negative 2 and y are married, we know they're multiplying, so I'm going to divide by negative 2 to get rid of them. That crosses out. Remember, there's always a hidden 1 in front of x. A positive divided by a negative is a negative. 1 divided by 2 is 1/2. Then I bring my x down. A negative divided by a negative is a positive. 4 divided by 2 is 2 equals y. All right, looking at my next problem, I'm going to go ahead and solve to get it in y equals mx plus b form and get that y by itself. So I'm going to subtract 2x from both sides to get the y by itself. That cancels out. Now I have 4y equals 8 minus 2x. Now the 4 and the y are married, so I have to divide them. So I'm going to divide by 4 to get that y by itself. So now I have y equals 8 divided by 4 is 2. And then a negative divided by positive is a negative. 2 divided by 4 is 1/2 x. Looking at these two equations, you should be able to tell me something about our solutions right away. I'm going to help you guys identify it. Look at our y-intercept here. Here it's positive 2. Here it's positive 2. Now let's look at our slope. Here it's negative 1/2, and here it's negative 1/2. So our pieces are the same, meaning our equations are the same. And whenever the equations are exactly the same, we know that that's an infinite solution. So when I graph it, I'm going to graph this equation in green and this equation in blue, and you'll see why they're infinite solutions, okay? So I'll start with my blue end. Again, I always start with my b, which is my number not attached to x, so it's 2. So I'm going to put a point at 2. Then my slope is negative 1/2. So that means I'm going down, and my rise over run is down 1 over 2. So I'm going down 1 over 2, 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 down 1 over 2. To go onto this left-hand side, I'm going to reverse and go up 1 over 2, 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 and up 1 over 2. So now I'm going to draw my line. So there's my first problem. Okay. Now I'm going to work on my second one, which I'm going to do in green. Again, my y-intercept is 2, so that's where I'm going to start. And I'm going to put my point at 2. Then my slope is negative, so I'm going down 1 and over 2. Down 1 over 2. Down 1 over 2. You guys seeing now why it's infinite solutions? It's infinite solutions because if I reverse here, up 1 over 2, they're the exact same line. So they're going to touch each other forever and ever and ever. Now, if I wanted to prove this via substitution, once again, I'm plugging in for y. So I'm going to cross out my y's here and set them equal to each other because they equal y. So I'm going to have negative 1/2 x plus 2 is equal to 2 minus 1/2 x. This time I'm going to bring my x's to the left and my numbers to the right. Again, it doesn't matter which direction you do it as long as x's are going a separate direction than the numbers. So if I'm bringing my x's to the left, I have to get rid of this one by adding 1/2 because that's the opposite of subtracting 1/2 x. So plus 1/2 x here, plus 1/2 x here. A negative plus a positive 1/2 cancels out. A negative plus a positive 1/2 cancels out. So now I have 2 equals 2, which we know means that we have infinite equations. All right, I'm going to move on to our last problem we're going to practice together today. If you need to pause, please do so now. All right, this is the last problem we're going to do together today. And I'm going to do it 2 different ways. I'm going to graph it, and then I'm going to show you substitution. So I'm going to start with graphing on here, and then I'm going to go into substitution. Okay, so again, with graphing, first thing I got to do is put it in y equals mx plus b form. Okay, so neither of my equations are in y equals mx plus b form, so I'm going to start on that. So I'm going to do 10x minus 5y equals negative 15. Center of my equation is the equal sign. I got to get y by itself. So I got to get rid of this 10x. Since it's a positive 10x, I'm going to subtract 10x. Anything I do to one side, I have to do to the other. That's going to cancel out. I now have negative 5y is equal to negative 15 minus 10x. Now I have to separate my negative 5 and y. They're married, which means they're multiplying. So I need to divorce or divide them by negative 5. Anything I do to one side, I got to do to the other. So those are going to cancel out. Y equals, that's a sloppy y, sorry. A negative divided by a negative makes a positive. 15 divided by 5 is 3. And again, a negative divided by a negative makes a positive. 10x divided by 5 is 2x. So now I have 3 plus 2x. So let's go ahead and graph that. So when I graph that, I start with my y-intercept, or my number not attached to x, which is 3. So I'm going to go to my y-axis, and I'm going to put a point here at 3. Then I go to my slope, which is 2. Okay, since it's not in a fraction form, I'm going to put it into a fraction by putting it over 1. Remember that it's rise over run, so I'm going up 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1. On the other side, I'm going to reverse it. Down 2 over 1, 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 down 2 over 1. And I'm going to draw that line. So there's my first line. So now I need to do the second line. But first, I have to convert it, once again, into y equals mx plus b form. So center of my equation is my equal sign. Trying to get this y by itself. So I'm going to add 2x to both sides. Oops, sorry, that's a positive. So am I adding? No, I am subtracting 2x from both sides. Sorry, guys, because the opposite of positive is negative 2x. 2x minus 2x is 0, so now I have negative y equals 3 minus 2x. What is the hidden number in between the negative and the y? Good, it's a 1. So now I'm going to divide by negative 1 to get rid of that negative sign. So now I have y equals, a positive divided by a negative is a negative. 3 divided by 1 is 3. A positive, or a negative divided by a negative is a positive. 2 divided by 1 is 2x. So now I have my second equation. So now, using that second equation, I'm going to graph it. So again, I start with my y-intercept, which is the number not attached to x. So in this case, that's negative 3. So I'm going to go down 3 this time. 1, 2, 3. Now, before I graph this, you might be looking, our slopes are the same. Okay, 2 and 2. But our y-intercepts are different. So what does that tell us that this is going to be? If you remember your characteristics, that means it's a no solution. Because whenever our slopes are the same, but our y-intercepts are different, we know that those lines are going to run parallel to each other and never touch. So let's see that on here. So our slope, again, is 2. So I have to put it as 2 over 1. Remember that that's our rise over our run, so I'm going up 2 over 1. So up 2 over 1, 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 up 2 over 1. And then on the other side, I got to reverse, down 2 over 1, down 2 over 1, down 2 over 1. And there are my lines. And as you can see, they're parallel, so they continue on forever and ever, but never actually touch each other. All right, so now we're going to do it as substitution. So if you need to pause to get all of this stuff done for your graphing, please do so. I'm going to move on to substitution now. All right, so I've shown you so far the easy version of substitution. But what I'm going to show you now is going to be a little bit different of an aspect of substitution. I've shown you kind of the basic aspect, but we're going to go further into it. Substitution is whenever you plug in for a variable based off what it means. Basically, what we're saying is variables are a nickname for something. So if I have y here, I'm saying that y is a nickname for something else. For example, think about my name. Students call me Miss Stiles, but is that my full name? No, it's just a shortened, respectful version that we use. My full name is Sarah Ann Stiles, but you wouldn't come into my classroom and say, "Hi, Sarah Ann Stiles, how are you doing today?" No, you would say, "Hi, Miss Stiles." Same thing with my friends. They use a shortened version of my name. They call me Sarah. They wouldn't come in and say, "Hi, Sarah Ann Stiles." They would say, "Hi, Sarah." We use our names as substitutes for our full name, but they still mean the same thing because it still refers to us. So think of variables in the same way. Variables are placeholders or substitutes of their full names. So whenever we're substituting, we can always just find what the variable's full name is and plug in. So we could do this with x or with y, but all we would do is figure out what it equals, either what x equals or what y equals, and then plug in that full name. I'm going to do it from y's perspective. So I'm going to say center of my equation is equal sign, and I'm going to find y by itself. I want to know what y equals. I want to know what y's full name is. Okay? So in order to do that, I need to get y by itself. So I've got to get rid of this 2x. To get rid of this 2x, I'm going to subtract 2x. Anything I do to one side, I've got to do the other. 2x minus 2x is 0. So now I have negative y is equal to 3 minus 2x. Remember that there's a hidden 1 here, and I've got to get rid of this negative 1, so I'm going to divide by negative 1 on both sides. That's going to cancel out. Now I have y equals, a positive divided by a negative is a negative. 3 divided by 1 is 3. A negative divided by a negative is a positive. 2x divided by 1 is 2x. So now I know what y's full name is. So y here is the nickname for negative 3 plus 2x. So what I can do is I can plug negative 3 plus 2x in for y here. And that's what I'm going to do. So I'm going to take my equation and I'm going to say 10x minus 5 times, and now I'm going to plug in my y's full name. Rather than leaving it as the nickname, I'm going to plug in the full name, which is negative 3 plus 2x equals negative 15. Now that I've plugged in the full name, now I can solve. So first thing I'm going to have to do is simplify. So I've got to distribute my negative 5 to both sides of the parentheses. Remember, when I distribute, I'm using multiplication. Okay, so I'm going to bring my 10x down. A negative times a negative is a positive. 5 times 3 is 15. A negative times a positive is a negative. 5 times 2x is 10x equals negative 15. Now I'm going to combine like terms. Remember that like terms are any numbers that are by themselves that you can combine, like 15 plus 2 plus 9 would all be like terms, or any numbers that have the same variable behind them. So any x's could be combined, any y's could be combined, any x squareds could be combined with other x squareds. So I have 10x here and negative 10x here, so they can be combined. If I have 10 x's, but I owe you 10 x's, I'm going to have 0 x's at the end of the day. So when they combine, they're going to become 0 plus 15 equals negative 15. 0 plus 15 is 15. Okay, so 15 equals negative 15. Do we know, does that make sense? Can I have $15 and negative $15 at the same time? No, I can't. So I know this is a no solution. Okay, if I wanted to, I could substitute using x as well. So let's try it with the x this time. This time I'm going to get x by itself. 2x minus y equals 3. In this case, I'm trying to figure out what x's nickname is, or full name is. Okay, so center of my equation is the equal sign. To figure out what x's full name is, I need x by itself. So I'm going to start by getting rid of the y. Since it's negative y, I'm going to add y. So plus y. Anything I do to one side, I have to do the other. Those two are going to cancel out. And now I have 2x equals 3 plus y. So now I've got to get rid of that 2. Since they're married, I'm going to divorce them by dividing by 2. So now I have x equals 3 over 2 plus 1/2 y. So now I can plug this in all the way right here. Okay? So let's do that. So now I have 10 times, and we're going to plug in x's full name, 3 over 2 plus 1/2 y minus 5y equals negative 15. So now I'm going to simplify. I'm going to take the 10 and I'm going to distribute it to 3/2 by multiplying and distribute it to 1/2 y. So let's do that. 10 times 3 is 30 over 2 plus 10 times 1 is 10 over 2y equals negative 15. Oops, I almost forgot my minus 5y here. Hold on. Let's fix that. 10 over 2y minus 5y equals negative 15. Okay, so then 30 divided by 2 is 15, plus 10 divided by 2 is 5y minus 5y equals negative 15. Okay, 5y minus 5y is going to cancel out to be 0, so now I have 15 plus 0 equals negative 15. 15 plus 0 is 15 equals negative 15. Again, that doesn't make sense, so this is a no solution. You can use whatever form of substitution works best for you. If it works best to find it in y equals mx plus b form each time and set them equal to each other for you, then use that. That works. If it works best to find the nickname and plug it in, use that. It works. Whatever method works best for you, that's the method I want you to use. So what I want you guys to do now is, if you haven't finished writing down this work, hit pause. All right, so if you're still with me, you have written down all this work. And what you're going to do is, for homework tonight, you're going to complete this last problem. You're going to solve it with both graphing and substitution. So you're going to graph it, and then you'll solve it with substitution. Okay, we're going to go over this problem as our warm-up tomorrow, so please make sure you get it done. Have a great day, Roadrunners.